The prerequisite for this chapter is speed, distance and time, and the link is given in the description below, so do check it out. So let's start with this. Relative speed in train travel. So what you have studied relative speed, right, in the physics of 11th and 12th, and you would have a perception that, oh my god, this kind of, not so good kind of chapter, right? But you know what, relative speed is basically only 2, okay? So let's get this started. So relative speed, let's have 2 scenarios. Let's learn relative speed using only just 2 scenarios, okay? So the first thing is that there are 2 cars, alright? Okay, this is a car for me. I hope it looks like one. Fine. So there are 2 cars. Alright? And this car is moving at a speed of s1 and this car is moving at a speed of s2. So both the cars with some full speed come towards each other, and you know what happens? They're going to come towards each other. They will obviously collide, right? So if at all they collide, so 2 cars coming at full force at each other, they collide, and one is going up to the sky and the other one is going down to the ground, okay? So let's just assume that kind of scenarios, okay? So they collide and one is going to go up and the other one is going to go down. So what can you see? You can see plus, right? Okay, this is for an easy remembrance method. So the relative speed will be equal to s1 plus s2. So you're never going to forget it, okay? So when 2 cars are going to come towards each other, they collide and one is going to go up to the sky and the other one is going to go down to the ground. So you can see an addition symbol, fine? If there are 2 cars and they are going to go in the same direction, alright? There are 2 cars and yeah, this is going to go this way and the other car is also going to go this in the same direction. Then what can you see? They are going to go in the same direction. Obviously, it's minus, alright? They are going to go in the same direction, so it's minus. So the speed relative is equal to what? S1 minus S2. So you're never going to forget it, okay? So if 2 cars are going to go in different direction, opposite direction to each other, then the relative speed is going to be S1 plus S2. If at all they are going to go in the same direction, then the relative speed is equal to S1 minus S2. And make sure that speed is always greater than 0. Alright? So S1 minus S2 must be done in such a way that the relative speed is greater than 0. It's not a negative value. Right? So let's look at a question so that you can apply both of these in a better manner. So let's consider this question. L and K are 2 stations 600 km apart. A train starts from L and moves towards K at the rate of 25 km per hour. Another train starts from K at the rate of 35 km per hour. How far from L will they meet? So let's represent it, pictorially, so that we can understand better. So L and K are 2 stations. This is station L, this is station K. A train starts from L. Okay, this is a train and it's starting from L, moves towards K at the rate of 25 km per hour. Another train starts from K, okay, at the rate of 35 km per hour. 35 km per hour. So how far from L will these 2 meet is a question. Okay. So right now what did we study? When 2 cars or whatever are going to come in the opposite direction, then what is the relative speed? Relative speed will be S1 plus S2. What? This is S1, let's suppose this is S1 and this is S2, which is nothing but 25 plus 35, which is 60 km per hour. Alright, so this is our relative speed. Okay, so what is the distance relative? You don't know the distance relative? Oh, no, you know. It is 600 kilometers apart. Alright, it's already given. L and K are 2 stations that is 600 kilometers apart. So the relative distance is given to be as 600 kilometers. So what is the time it takes to cross? What do we know? Speed is equal to what? Distance by time. So time is equal to what? Distance relative divided by speed relative. So what is the distance relative? It is 600. Divided by what is the speed relative? It is 60. So it takes 10 hours for both of these trains to meet each other. Fine. But what is the question? They never ask what is the time taken. How far from L will they meet is a question. So they are going to basically meet at when the time hits 10 hours, they meet each other. So how far from Lonavala are they going to meet is a question. So how far? They are asking you for the distance from Lonavala. So distance equal to what? Speed into time. Speed of Lonavala train into the time it takes to meet. Alright. So speed of Lonavala train is 25 into the time taken is 10. So at a distance of 250 kilometers from Lonavala, both of these trains are going to actually meet each other. Alright. I hope it makes sense. So let's see a variation of this question, right? So let's consider this variation question. L and K are two sections 600 km apart. A train starts from L and moves towards K at the rate of 25 km per hour. After 2 hours, another train starts from K and moves towards L at 35 km per hour. How far from L will they cross each other? It looks more similar to the previous question that we actually did right now, right? But what is the only difference here? I hope you have got it, yeah. It's after 2 hours, alright? So let's write this picture. Fine. There are two stations, L and K, and they are known to be 600 kilometers apart. Alright, they are 600 kilometers apart, and a train starts from L at a speed of 25 kilometers per hour. Fine. So suppose that it's starting at 10 a.m. Alright, fine. After 2 hours, that is at 12 p.m. only, another train is starting from K and moves towards L at the rate of 35 km per hour. So what can you say right now? Within the 2-hour time duration, right, the train from Lonavala would have covered some distance, right? So at 12 p.m. Lonavala would have covered some particular distance. So how do I find it out? What is distance? Distance is nothing but speed into time, right? So here we have to consider only the speed of the Lonavala train, because this train did not even start yet. Only the Lonavala train is going to move. So what is the distance it covered in 2 hours is what we have to find. So what is the speed? Speed of the Lonavala train is 25. In how many hours? 2 hours. So it would have covered a distance of 50 kilometers already. Alright, so this is 50. So the remaining distance is 550. Alright, so Lonavala train at 12 p.m. is going to say 50 kilometers from Lonavala. It had already covered this much distance. So you have to calculate from here. So you have to only look at this part. This is the same as previous situation. Alright, there are two trains. The distance between them is 550, and right now you have to calculate the relative speed. The relative speed will be equal to what? This is S1, this is S2. So S1 plus S2, because they are going to go in opposite direction towards each other. So it is 25 plus 35, which is 60 km per hour. And what is the distance relative now? The relative distance between the two at 12 p.m. is going to be 550 km. Okay, so the time is nothing but distance relative divided by speed relative. The time at which they cross each other or they meet each other is going to be what? Distance relative by speed relative, which is nothing but 550 km divided by speed relative is 60, which is 55 by 6 hours. At 55 by 6 hours, they are going to meet each other. Fine. So what is the distance? How far from Lonavala will they cross each other is the question. So distance from Lonavala is nothing but what? Speed into time. Alright, which is nothing but speed of the Lonavala train into the time taken. This is this time. Alright. So speed of the Lonavala train is 25. 25 into 55 divided by 6. Okay, so 25 and 55 by 6 will be 229.166 km. Alright. At distance of 229.166, they will meet each other. But from where? When they start, we are considering this to be the starting location. Alright. So if this is the starting location, the distance will be 229.166. So at a distance of 229.166, they are going to meet. Alright. But we never considered this 50. So they are asking you how far from Lonavala or from L, right? So 50 plus 229.166 must be considered. So if it's 50 plus 229.166, it will amount to 279.166 km. Alright. So at a distance of 279.166 km from Lonavala, they meet each other. The two trains will cross each other. Right? So I hope you understood this.